So in this lesson, we'll be going through calculating the sum of a geometric series. So the fundamentals that you need to know on how to calculate the sum of geometric series is really two sum formulas. The sum of n terms is equals to a r to the power of n minus 1 over r minus 1. And the second formula is sum of n terms is equals to a 1 minus r to the power of n divided by 1 minus r. So what distinguishes these two formulas is that really for this first formula, you need to know that your r value needs to be greater than 1 to be able to use it. And also for this formula, r needs to be less than 1 to be able to use it. So really those are the two distinctions really that distinguishes the two formulas. So let's consider the example really that we're given to calculate the sum of a geometric series 2, 4, 8, and they're telling us that up to 14 terms. So what we need is to determine what our a value is. We need to determine what our r value is, and we also need to determine what our n value is. So from the series we can see that a is equals to 2, so we can determine our r by saying 4 divided by 2, which gives us 2, and say 8 divided by 4, which is 2. So our r value is equal to 2, and our n value, we're told that 14 terms, so it's 14. So we need to choose the formula that we will use. Our r value is 2, and 2, we know that 2 is greater than 1, so we're going to be using that formula to calculate the sum. So therefore, the sum of 14 terms will be equals to the a value is 2, the r value is 2, the power of 14 minus 1, all divided by 2 minus 1. And go to calculator and punch in all that and see what answer you get. 2 minus 1, and getting 32,766, and that will be the sum of 14 terms, and we will get our full marks. So let's move on to the next question, where you're asked to calculate really the value of n, for which the series is equal to 16,300 and 383,5, and where the first term is equal to a half and the constant ratio is equal to 2. So we are given that the first term is a is equal to a half, and we're also given that the constant ratio r is equal to 2. But we are told that really the sum, this really series, is equal to s at n is equal to 16,383,5. So we're asked to calculate what n is, and n is unknown. So we know that our r is 2, which means r is greater than 1, which means we're going to be using the formula s at n is equal to a mark squared r to the power n minus 1 over r minus 1. We know what Sn is. We are told that it's 16,383,5. We know what r is. It's 2. We know what r is. It's 2. We know what a is. It's a half. So we just substitute and we calculate the unknown. Let's go ahead and substitute. We have 16,383,5 is equals to our a value is a half. Our r value is 2 to the power of n minus 1, all divided by 2 minus 1. And really, then the denominator 2 minus 1 will just give us 1, and really we can multiply everything by 2 so that we get rid of that half, or divide both sides by half. And if we divide both sides by half, we'll get 16,300, or rather, let me show it step by step so as to not confuse. 16,383,5 equals to a half, 2 to the power of n minus 1, continue our working there, we can divide both sides by a half, and we'll get 32,767, which will be equals to 2 to the power of n minus 1. We can take the 1 to the other side of the equation. It will add 1 to 32,767, for which we have 32,768, which will be equals to 2 to the power of n. And then we'll go and use logs, because we know that when we're given an exponential equation, for example, a to the power of n, and we're looking for the exponent n, what do? We apply logs and say the log of a y is equal to the exponent n. So really we'll be applying the same knowledge there, which means we'll have a log 2 to 32,768 is equals to n. And if we punch in the calculator, go to the log daily function and say 32,768, you'll see that your n value will be equals to 15, and that will be our n value. So we can move on to the next question. Now we're given the geometric sequence, but it was meant to be series, and then the first term is equals to 3, so we know that our a value will be equals to 3, and the seventh term is equals to 3 over 64. So therefore we're asked to determine what the sum of 10 terms is. So what we know that is a is equals to 3, and we know that t7 is equals to 3 over 64, and we're asked to calculate what the sum of 10 terms is. So what we need to know, the Tn geometric series is a r n minus 1. So really let's rewrite T7 in terms of that. It will be T7 is equals to, we know our a value is 3, and it's equals to r to the power of n is 7 minus 1, but we're told that T7 is equals to 3 over 64, which is equals to 3r to the power of 6, and we can go ahead and divide both sides by 3. We'll get 1 over 64 is equals to r to the power of 6, and r is equals to 1 over 64 to the power of 1 over 6. And if you punch that into a calculator, you should get an answer of 1 over 2. Means our r value is 1 over 2. So far, let's recap. What do we have? We have our a value to be 3. We have our r value calculated to be 1 over 2. And we are asked to calculate what the sum of 10 terms is. So if our r is a half, we know that we'll be using the formula, the sum of n terms is to a 1 minus r to the power of n over 1 minus r. So let's go ahead and substitute. So calculating the sum of 10 terms means n will be 10, our a value is 3, 1 minus a half, which is r, our n will be 10 over 1 minus a half. So the sum of 10 terms is equals to, we go back to our calculator and punch in all these values and see what we get as an answer. 1 minus a half as the denominator, and we're getting 5,99, and that will be our answer when we find the sum of 10 terms. And let's move on to the next question, which says consider the following geometric series, and then we're given the geometric series. We're asked to calculate the value of k for which the series will converge, and the second question is to calculate the sum to infinity. So what we need to know really about convergence is that our r value needs to be between -1 really and 1. If it's between -1 and 1, our series will converge. If not, it will be divergent. So what we need to know, what we need to do, the first question is to calculate the value of r and then find the values of k for which it will converge. And how we do that, simply by saying this is our geometric series. 2k plus 1 to the 3, and we calculate our r value normally by saying t2 divided by t1 and we'll say t3 divided by t2, and we'll see that these will cancel, that will cancel, you'll be left with 2k plus 1, these will cancel, that will cancel, you'll be left with 2k plus 1. Means our r value is 2k plus 1, but they said you must calculate the value of k for which it will converge. So therefore we substitute our r value and then really now we need to solve for k. How we do that? We can subtract throughout this equation. Subtract -1 to get rid of this +1, so it will be -1 is greater than 2k plus 1 minus 1 is less than 1 minus 1. See, that will get -2 really. Then we have 2k because 1 minus 1 is 0, and we'll get 0 because 1 minus 1 is 0, and we divide throughout by 2, and divide throughout by 2, and you see that we get -1, and k is greater than -1, k is less than 0. So the value of k needs to be between 0 and -1, and we would have answered the first part of the question. So the second part of the question says hence or otherwise. So whenever they say hence or otherwise, it means that we have to use the previous answer to answer the second question. And how do we go about that? So let's just write what the value of r is. It's 2k plus 1. And I need to erase this so that we answer the follow-up question. It's 2. We're asked to calculate the sum to infinity if k is equals to that value. So we're given that k now is equal to -2 over 3. -2 over 3 actually does lie between 0 and -1. So meaning that our r value will be equals to, remember our r value is 2k plus 1. We're going to substitute our k value, -2 over 3 plus 1. And we need to calculate what our r value is, so we can start working with it. See that our r value is -1 over 2, and we just apply that to the sum to infinity formula, which is equals to a 1 minus r. Our a value of our sequence, we can quickly calculate our a value of a sequence, which is simply 3 2 times k plus 1. So we say 3 2 times the k value is -2 over 3 plus 1. Then if we punch this into the calculator, we should get our value for a. And our value for a is -1. So what we just did is we took this a value here and we substituted the value of k, which is that to find our a value. So a value is -1 over 1 minus our r value, which is -half, and our sum to infinity will be -1 over 1 minus a half, which will give us -2 over 3. And in that way we would have calculated really our sum to infinity.